Hi, this is video 2 on random variables. In this video, we'll discuss about probability distribution function. But before that, let me define what discrete random variables are, because there are two types of random variables. The first one are discrete random variables. The second one are continuous random variables. So as I said before, we are focusing only on discrete random variables. These are the random variables whose possible values either constitute a finite set or can be listed in an infinite sequence. So for example, there is a first element, a second element, and so on, right? So either countably finite or countably infinite. So something that we can count maybe, right? So this is discrete random variable. Good news is that we are not covering continuous random variables. Okay, so then let's move on to what is probability distribution function, and an important aspect of random variables. So in the previous part of this lecture, we saw that we were able to calculate the probability for a random variable for different values, right? For different real numbers. For example, what is the probability when x equals 2 and so on, right? So if we are able to get the probability of each possible value of x all together in a more organized way, that is what a probability distribution function essentially represents, right? So before we actually go and calculate a probability distribution function for a given experiment, let's see how it's denoted. So the probability distribution function for any experiment is denoted like this. So this is read as, this is the probability for random variable x. So this is the x to take any value. This is like lowercase x, right? So essentially we are saying that for all possible values of x equals x, and this x can take all possible values. All possible values. Okay, right? So let's look at an example to better understand what probability distribution function means. Okay, find the probability distribution function corresponding to the random variable x from example 2. Let's quickly look at what example 2 was. Here is example 2, right? Tossing 3 coins, x is the number of heads, right? So we are supposed to find the probability distribution function, or in short, it's also called PDF, right, for this experiment. One really easy way of doing that is to tabulate all possible values that x can take, and then all possible probability values for like each of x. And this is going to be the entire probability function, right? For x, and this will be probability x over all possible values of x. So now we know that x can take 0, like 0 heads, right? Or 1 head, or 2 head, and 3 head. I don't know why I drew this weird big table. Maybe let me get rid of that part. Okay, great. So let's go back, drawing our table a little smaller. Okay, so here we are, right? So for all these values of x, when x is 0, 1, 2, 3, what is the probability value, right? So what is the probability when x is 0? So no heads. We saw that the probability of each of that outcome, there is just one possible outcome, that is when all tails, right? So we get 1 over 8. Okay, how about getting 1 head? I think to get 1 head, we have 3 possible sequences, right? So 3, 8, and then the possibility of getting exactly 2 heads is also 3, 8. We can go back and check all of these, and then getting 3 heads, there is just one such possibility, which is 1, 8, right? So this entire sequence of values here is my probability distribution function. A better way to visualize this is usually graphically. So let's actually draw that here. Let's say on this side is my probability, the PDF, right? And here is the number of heads. Heads, that's x, right? So I have this 0 step, 1 step, 2, and 3, and this is all the possible values that my x can take. And let's assume here I have these divisions, 1/8, 2/8, 3/8, because this is the maximum possible, right? So here, to get this like a 0, and I'm drawing it like as a box, is 1/8 from this table, and then getting 1 is around 3/8, right? So I'm drawing this bar chart sort of a thing, and then getting 2 is also 3/8, and then it comes back to 1/8, right? So this graph represents the probability distribution function for the experiment when I can toss 3 coins. Right? We'll look at some more specific random variables later in this lecture where we'll see how the graphical representation works for them, right? So with this, I end video number 2. In the third video, we'll begin talking about joint PDF, right? So considering two random variables jointly.